Hello everybody and welcome to the whitchermath channel and remote learning for COVID-19, homeschooling, whatever you want to call it. Here's a little something I sent out to you, my 8th grade students, a day or two ago. And this little video, even though it's on white paper with black lines, the slides I sent you were beautiful red colors and everything else. So I'll do my best to color it up a little bit here. Okay, it's been close to a month since I've seen you in person, and I'm a little shy, so I'm off camera, of course. But step one, slide one from those slides I sent you, was to copy this shape onto your own graph paper. Fortunately, I just printed it and it's already done. But one thing I need to do is label these coordinates just for review's sake. I'm not trying to insult you, but remember this is the x-axis, which is horizontal, and this is the y-axis, which tracks vertical movement. We've got lots of noise going on here. I'm in the laundry room. You can hear my dog Ted barking. You can hear guinea pigs hopping around in their cage in the distance. But anyway, I'm going to stay focused. Right one, up one. I'm just keeping track of each vertex. And more than one is vertices, of course. The vocab, so important. 2, 3, 4, and 1. These are all positive y's, positive x's over in here. 1, 2, 3, 4, 1, 2, and 1 and up 2. 1, 2. Okay, so I've got them all labeled. So copy, check. Here's a verb, multiply, tells me something to do. Copy, multiply, graph. So everything times 3, I'm going to do my work over here. I'm going to call this vertex A, B, C, D. I know that is so creative, right? So creative. And there's a notification. But if I go times 3 on everything, I'm going to show my work over here with blue. Yay! Okay, so if I go A, B, C, D, A is 1, 2. Multiply everything by 3. I get 3, 6. For B, I have 4, 2, everything times 3, I get 12, 6, because 4 times 3 is 12. Vertex C is 4, 1. I'm only going to do one take here, so I want to go slow and get it right. Plus, it's embarrassing to make a video and get something wrong. Finally, D is 1, 1. What is 1 times 3? Right. And again. Okay, so this down here is our pre-image. That's before we do all the regraphing. So I multiplied all the coordinates by 3. Got it. Now we'll graph the new shape. And we're going to label it with the little primes, right? A prime, we call that, which means image or after. Okay? All right, here we go. Let's not stall anymore. A is going 3 over 3 up 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. There is A prime. B is going 12, 6. Woo! Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Uh-oh, got a guess. 10, 11, 12. Fair enough. You think that's about 12? And then up 6, about over here. Sometimes we have to estimate. What is this one? B, what's this thing called? Prime, right. B prime. Now I need C prime. I already know that I'm going to estimate over here that that's 12. And I want to go up 3, which would put me crazy. A vertex right there at the word vertex. I did not plan that, but it's kind of cool. And finally, D, 1, 2, 3, 1, 2, 3, becomes D prime. Boom! Okay. I've got my new after vertices, my primes. I'm going to connect the dots best I can. Just a little review here, no big deal, no test tomorrow. Just seeing if you remember how to do dilations. We just barely started on them in class, and then this whole weird stuff started happening, and haven't seen you in a while, but I want to continue this. This is not new, for sure, but we call this the image. It's after, because we have the primes. And just for fun here, like using a projector, I am going to I'm going to connect the corresponding, meaning the same vertex in the same place on a similar shape, corresponding vertices. I'm going to draw some lines here. I'm going to connect A to A prime. Ooh, that was kind of rough. I'm going to connect D to D prime. How about B to B prime, corresponding, same spot on a similar shape. And finally C to C prime. And that makes it look like kind of a 3D projection. Like we started here and then it's kind of projecting out away from the origin. Remember, origin is the center of the graph where the x and y axes intersect. Okay, now we have a second job to do because I sent you a second slide. And the second job to do is start from scratch, go back to the same pre-image, and same pre-image. And what are we supposed to do? Do you have that slide handy? The directions are multiply all vertices. I may be paraphrasing, I'm not exactly sure, but multiply all the coordinates by -2 and then graph. So we copy, we already have it, pre-image. I'll just kind of highlight it that we're starting over. We're not starting with the image, the blue thing. We're starting over with the pre-image. Multiplying everything by -2. That's our scale factor. All this vocab coming at you. Remember, I also sent out the Quizlet for transformations, which includes all of this vocabulary. So if you need a little review there, some of this not making sense, corresponding, vertices, the prime, image, pre-image, all those kind of words. If you need a little review, go check it out. And finally, we're going to graph this, and then we'll be done. Okay, let's go. If you need to pause the video, do the work, and then roll it, that is totally up to you. It's your learning, you're in charge. Here we go. I'm going to scoot the paper up a little bit. Okay. So, let's take A, B, C, D. Can you still see this way over here? Okay. And we're starting with 1 and 2. Same coordinates we started with last time. 4 and 2, 4 and 1, 1 and 1. Now our scale factor is going to be -2 this time. So we're going to change the sign on all of these and double them. So we're going -2, -4, -8, -4, -8, -2. Since all the signs were positive, they're all going to be negative now. Sorry about that. Sorry to go so negative on you. I'm going to double check my work. As you know, especially 4th period, I've been known to make a mistake or 5 in a class. Good. Those are 8s. That's another 4, a 2 and a 2. Very good. Okay. Oh yeah, of course, these will be called the primes. I'll label them that way. -2, 1, 2, 3, 4, -4, -8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, bomb, 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 -8, -2, and -2, -2. That's a good sign. We still have a rectangle. It's a similar rectangle, meaning all sides, dimensions, measurements have been multiplied by the same thing, -2. That same thing is called the scale factor. And now we have, let's see what happens when we have a negative scale factor greater than 1. The shape got bigger. So it's an enlargement, and it's in an opposite quadrant. I'm going to go ahead and draw some connecting lines. I hope you find this interesting. So I've got, if this is D1, closest to the origin, this would be D prime. This is A, we go around the clock, A, B prime, C prime, D prime. Check it against my coordinates, make sure I didn't mess up. But here's the fun part. I'm going to start with the D. I'm just going to connect the corresponding vertices like we did the first time. Here's the A. Weird. Look how they crossed. Crazy. What do they have in common? Spoiler alert. You can go ahead and shout out because no one else can hear you, so it's all right. I'm going to connect B to the new B prime. What's this called after we do this? Right. It's called the image. We started at the pre-image. And then finally I'm going to take the C from the previous image. Oh no! Did I mess up? I went from image to image. Let's go back to black, just like Amy Winehouse. I'm going to start here with this D. I'm going to start here with this pre-image A. Do you see what's happening here? Catching on. Here's B from the pre-image. Here's B prime. And finally, here is C to C prime. Isn't that crazy? So if we use the origin as like this vortex, the matrix pass-through point, the matrix, the vortex, it's a wormhole into a different dimension of space. I don't know, but check this out. The negative sign took the pre-image, sucked it in through the origin, and spit it out the other side in a slightly different orientation. So it didn't just slide down like that. It did a 180, came down here, and then it exploded a little bit. And even if we compare the two images, did you notice that? This B passes through that B, goes through the origin, and connects with the third one. All of the B's align through the origin. Crazy! Wow, thanks for playing. That was a super long video, but hopefully it's a useful review on how to do dilations. In this case, our point of dilation, was the origin. That is it. Thank you. Good to see you. No, I can't actually see you. Sorry. Next time. Thanks for watching.